Okay, this is going to be about taking derivatives of expressions involving e, which is Euler's number. And I'm on page 195, and I'm doing similar problems to that. So the first thing that you have to know is the formula for the derivative. So the derivative of e to the u is e to the u times whatever the derivative of that exponent is. So in this first one, and let me change my pen color, we have the derivative of y is going to be keep the first part the same, and then you're going to take the derivative of the exponent, which in this case is x squared, so the derivative is 2x. So that would be your answer. If you have it written like this, that's the same thing. Okay, on the second one, first of all, that 5 just sits out front. He doesn't involve himself in that at all. So this is going to be e, and then keep the exponent the way it is, and then multiply by the derivative of the exponent, which would be negative 2. So in this case, it'd be negative 10e to the 3 minus 2x. On this last one, we keep this first part the same. So all of that stays the same. And then we multiply by the derivative of the exponent, which is 10x minus 2. Make sure that that 10x minus 2 is in parentheses, because if it's not, you have the wrong answer. Okay. Number 4, we need to use the chain rule. So this 3 is going to have to be taken care of first. So we have 3 and then ex minus 2, and that's all squared. And then we multiply that by the derivative of the inside, which is just going to be e to the x. Okay. On number 6, we now have the product rule. So it's this times this. So I'm going to keep the first one the same and differentiate the second part. So that's e to the 5x times 5. These are all being multiplied. Okay, plus, now I take the derivative of the first part, which is 2x, and keep the second part the same. And you could further simplify this and say that this is going to be 5x squared. Actually, let me even take out an x. So, whoa. Okay, so both terms have an e to the 5x and an x. So e to the 5x times x, and then left inside is going to be 5x plus 2. So that would be the most simplified that you could go with that. Okay, on number 7, we're using the chain rule. So first we have to take the derivative of cosine, which is negative sine. Keep the angle the same. Okay. Now we take the derivative of the inside of that, which is going to be e to the 2x, and then the derivative of the inside of that, which is the 2x, would just be 2. So you could reorganize this if you wanted to something like this. You could even put the e out front. It doesn't matter. Okay. Number 8, again, is going to be the chain rule. So the first thing we're going to take the derivative of is the e, which is just itself. So e to the tangent x is the first part. Now we take the derivative of the inside, which is tangent. So that comes out to secant squared. And then the derivative of x is just 1, so we don't have to worry about that. Okay, on number 9, natural log is going to be 1 over the original part. So 3x plus e to the 2x. And now I'm going to take the derivative of the inside of that, which is 3 plus 2e to the 2x. And you could rewrite this so it's all one fraction, which is conventionally how we see it. So it would look like this. Okay. Number 10, you need to use the quotient rule. So it's going to be low d high minus high, and then d low is still e to the x, all over low, which is e to the 2x. So if you simplify that a little bit, whoops, that was supposed to be, oh no, that's right. We have 2 minus x over e to the 2x. And one of these actually cancels, so you could simplify it to x times 2 minus x. Whoops. Okay, there's an x there. 2 minus x there, and then e to the x in the denominator. Let me pause this for just a second. Okay, so now number 12, which is the last one here, we have let me rewrite this before I start. So we have e to the 2x to the 1/4 power. So we're going to do the chain rule. 1/4 is first, and then e, and then 2x is last. We have three different things to take the derivative of. So it's going to be 1/4 e to the 2x to the negative 3/4. Okay, and then the derivative of e to the 2x is e to the 2x, and then the derivative of 2x is 2. So if we simplified that a little bit, we'd have 1/2 e to the 2x to the negative 3/4 times e to the 2x. So the 2 and the 1/4 got combined. And then you could even simplify this a little bit, because really this would be, let me put the 1/2 there. So 1/2 e to the 2x, and it's going to be negative 3/4 plus 1 because of this. This is the 1 here. So you could simplify this to 1/2 e to the 2x to the 1/4. And if you wanted to even go further, you could say e to the 1/2 x by multiplying the 1/4 and the 2. So this would be your super simplified answer.